I've been flying FPV for over 6 years now, both freestyle and racing. For the longest time, I thought that super responsive twitch controls is what I need for my racing, as opposed to dulled down, slow or smooth controls for freestyle. Turns out, I couldn't have been more wrong. My name is and today we'll explore the secret to precise flying called rates. Before we can talk about rates though, we need to finish our build and set up your receiver. Now, those of you who have no idea what I'm talking about, you probably want to check out my first 2 parts of this video. This is a series where we're building a drone that's suitable for beginners, that's based on the HD FPV system by DJI. So if you haven't seen it, pause this video and I'll have a link there or definitely in the description to see the 2 parts. There's a hardware build and then there's some configuration of the motors and the drivetrain, the speed controllers and everything. So you definitely want to check that out. But the last thing we didn't do is configuring the receiver. Now, it's going to be easy, but we have to do it. So let's dive in. I've been using the long-range system by Team Black Sheep called Crossfire, simply because I've had great experience with it and I don't feel the need to purchase a radio by DJI that operates on 5.8 gigahertz band. In this case, both the setup and configuration is close to identical for both systems, and I will do my best to provide theoretical info on how to proceed with the DJI radio. You're not limited to these 2 systems, but your mileage may vary. As the all-in-one flight controller only has limited number of I/O or UARTs, we need a single cable to go to the S-bus pin on the flight controller. That and the 5-volt power provided is all we need to get the hardware part of the receiver hookup done. Before we configure the flight controller, we need to make sure that the receiver is bound to the radio first. Follow the tutorial that's linked below in the description on how to do it with the DJI radio. I will assume you know how to do this if you use the Crossfire system like me. Once we have the receiver bound to the radio in either case, we proceed with the config in the Betaflight Configurator application. So let's start with the port. The flight controller we use has the S-bus port set on UART 1. So in the ports tab, enable serial RX for UART 1. You can also see me set up UART 6 to MSP to allow the DJI system to communicate with the flight controller. You have to hit save and reboot for this part. In the configuration tab, we'll switch from PWM to serial protocol and select S-bus from the list. This is true for both Crossfire and the DJI radio case. When we save now and switch to the radio setup page, we should see the channel indicators change as we wiggle the sticks. And the last thing we need to set up are the switches. So in the modes tab, we will set up a switch to arm the quad.
Another one to set up the beeper so that you can hear the quad if you crashed in high grass or some such. And then the last thing is what's called turtle mode, something to flip the quad when it's upside down, which is super useful when it's like in an inaccessible area. You crashed somewhere and then you still have a chance to flip it and possibly fly back to somewhere you can reach.
The receiver setup, and now the voodoo, which is how to set up your rates. Rates define how your quad responds to your stick input, and it's one of the most important things, the throttle curve and the rates. So let's head over to the next location and I'll show you how to configure those rates.
We've had way too much fun in Turin and its amazing bandos, so you'll have to excuse me for forgetting to record anything on rate at the location. If you want to see the whole edit from Turin, click on the card above or find a link in the description. But let me finally explain the sorcery called rates. Just like with everything in life, the secret to having smooth footage is not configuration. It's investing a lot of time and practicing. But the configuration can help, but it begins with the controller itself. There's many variables. It's not just a single configuration that will apply to every kind of controller. Remember, the controller here is not just a device to suggest the next location of your drone like it is with the DJI stuff. You actually have direct control of the quadcopter. You angle it slightly more and you have to compensate with the throttle to remain at the same altitude. You are controlling the drone, not some flight controller software. The most important thing to flying an FPV drone is throttle management. Throttle management is way easier with a good throttle curve. Nobody will tell you that as a rookie. You will hear all about the PIDs and filter and all sorts of technical noise. But to be able to fly quads that are very different from another, the throttle curve is what will make them behave at least similarly. A heavy quad will usually respond slower to an abrupt change of input. There is lots of mass to move around. This is lots of fun to do as a freestyle pilot, as you can freely look around and track other objects as the quad continues on the previous movement vector due to inertia. A light quad, on the other hand, is super twitchy. Without adjusting the throttle curve, it may hover as low as 10% of the throttle, and even a slight movement of the sticks will result in a quick change of direction. This is almost impossible to control in tight spaces, and many pilots shy away from ultralights for racing. This is where the magic of throttle curve comes handy.
By default, there is no throttle curve. There is just a linear interpolation. There is a line between the input, wherever your stick, the throttle stick is, and what the flight controller sees as the throttle value. I'm going to use this guy as an example because it's, you know, the most extreme case that I have. It's super light, and you know, if you wouldn't touch the throttle curve, it would hover at like, you know, 10 or 5% of the range of the throttle stick. So this tiny little movement would make it go up and down, and it would feel like it's fast, but it's not really that it's fast, it's just twitchy. It's super responsive to the input. And that's not good because, you know, as you're trying to come out of the corner, or as you're angling it, you're gonna be working the throttle. And if you have so little space to move, I mean, it's possible you can train to do anything, but it's harder than if you have more motion available for that thing, because at the 50% and up, you don't need that much resolution, because it's just like it's going fast and super fast. But at the bottom, you're like controlling, as you're changing the angle, you need to raise throttle corresponding to that angle so that you remain at the same altitude. So it's very important to have fine control at the bottom half of the curve. So let's see how that's done in the configurator.
The curve is somewhat weird by default because it's mimicking all the other axes. When there's no expo, you just get the line, but as soon as you change the expo, you will see that the curve mimics what we have for roll, pitch, and yaw, meaning like it thinks that the midpoint is somewhat special, which is not the case. Usually, you want to make the bottom of the curve insensitive. So you want to move the midpoint all the way down. That's what I do. I just set it to 0, and thus it's very insensitive at the bottom half of the curve, and then it goes up. So I move the expo to set the midpoint to be at half of the stick, and just keep the midpoint all the way down.
So now that we got the most important thing, that's the throttle curve, we can look at the other axis, that's the yaw and pitch and roll. And those are all the same. The only difference to the throttle curve is that the important part is not at the bottom of the curve or the bottom of the range of the input, but in the middle. So we really worry about keeping the middle very insensitive and having the rest of our range just for the ends, because we're really only going to use those on really sharp turns. And you know, for cinematic flying, we don't really need some extreme speeds for the spinning, so it's not going to be as extreme. But some pilots like very fast turns and do like really fast spins, and that's going to only happen at the end. So let's take a look at how that's done in the configurator.
So the RC rates configuration happens in the PID tuning tab. There's the column all the way on the right that tells you what is the maximum speed using your settings. So if you deflected the stick all the way to the extreme, how fast would the quad turn? And it's in degrees per second. So that's like your real world speed of the quad turning. Then you have the RC rate, which kind of tells you the steepness of the curve. So that's like your primary setting of how fast you want it to turn or not. And then there's two columns, and the reason why there's two is historical. Like they kind of do the same thing but differently. So I recommend not combining the two, just stick to one or the other. The RC Expo way will maintain your maximum speed on the extreme, but will change the curvature. And I don't like that because you can't really compare your mid stick, which is what, you know, the insensitive part that really tells you how the quad is flying, and it only focuses on the maximum deflection, which is not something you're doing very often. And you can't really compare if you have two pilots and you want to compare how fast your rates are. You don't have a value. You don't. The RC rate does not tell you anything if you use Expo. So the super rates is what I believe it was KISS Flight Controller that introduced it, and Betaflight kind of only introduced it to be able to match the behavior easily. So that one will kind of keep the slope of the curve in the middle, and just the super rates only affect the end of the curve. So you set your kind of rate as if it was linear, and then you just tweak the super rates to get the super fast speed, on the extreme deflection. So as a recommendation, now you're seeing my rates there, which are very slow. It's around 400 degrees per second on the extremes, and it's a very shallow. It's the default is 1 for the RC rates, and I use half of it. So it's very slow in the middle, very insensitive in the middle, and only at the extremes it kind of goes faster. But it's still like, when I started, I liked the quick flicks, the flippity flops, and I was using like 1200 degrees per second, and now I'm using a third of it. So that's the secret to having a smooth footage. The good thing about trying to tweak this and finding the rates that suit you is that you can use the simulators. And we'll talk a little about it. Maybe I'll do a bigger video about it, because it's an important part of the hobby. But right now I'm just gonna focus on the rate setting in those simulators. You're now spoiled with choice for simulators. I'm not gonna spend too much time on it because it probably deserves a whole video. But there's 3 I'm gonna pitch. One is Velocitron, which I would say is the one with the best flying physics. There's Liftoff, which I think was one of the first ones, and it's got decent graphics and it's fun. And the third one is a very recent addition. That's DCL. All of them work on Windows and Mac OS. DCL doesn't work on Linux. The other 2 do. They're all pretty much great in the aspect that's now important for us, and that's configuring. All of them allow you to set the behavior of the quad using the exact same method as you do for your real quad. I mean, it has Betaflight configurator built in, so you're going to be using the same rates and super rates or RC Expo just like you would on the actual quad. So you can actually tweak it, fly it, tweak it again until you're happy with how it flies. Of course, it's a simulator. It doesn't actually fly exactly the same as your quad because, we talked about all the variables that affect the behavior of the quad, but it's a really good start. And I have to say that you can switch between the sims and still get a very similar behavior just because you're using the same rates, completely ignoring the PIDs because that is not as important as nailing all the other stuff.
So that was all about rates. You now have a drone that you can practice with. I do recommend you start with the simulator, as I mentioned. I might do another video about simulators if there's enough interest. I started editing this video like you know, early this year, so it has taken me quite a while. So unless there's a lot of interest for that simulator video, I'm just gonna populate the channel with my flight videos. In any case, I hope you enjoyed it and take care.